So our next topic is finite representation. Problems. In TOC, a problem is a question of deciding whether a given string is a member of some particular language. Just consider sigma equal to a comma b, two symbols. Then language L1 is a set of all strings of length 2, which means L1 is a language which contains the strings of their length exactly 2. So the problem is here, I just want to check whether this string s equal to ba, whether this string is present in this language or not. So I can use any algorithm like linear search. You can go through linear search and search whether this string is present in the language or not. Using linear search, because it is a finite set, using linear search you can check whether this string is present or not. Just take another language L2, set of all strings starting with symbol A, which means L2 is a language containing the strings with their first symbol A. So here I want to check the string equal to BBA, whether this string is present in this language or not. Just by looking at the first symbol, you can tell that it is not present in the language. But the machine does not think like human brains. It needs some algorithm to check. So if you go through linear search, it may take forever time to produce the output for this question, because here we are not telling to where to stop the checking. If you go through linear search, it goes on checking for the string BBA, and it does not find this string forever. So we need some representation to tell, even if the language is infinite, we must able to tell that if I pass any string, the string is accepted or not. So what is that? So what is the way of telling whether this string is accepted or not? So for this question we are going through finite representation. Take the same example, L2 equal to set of all strings starting with A. That means the language L2 should contain all strings with starting symbol A. So what I want to tell is, this L2, which is infinite language, I want to represent this L2 in a finite representation, so that finite representation is nothing but a finite automata. I will tell about finite automata in the next class. So this L2 is represented in a finite representation, which is finite automata, so that if I pass any string, I should get an output that yes, the string is present in the language, or no, that means the string is not present in the language. So the finite representation is a finite automata, which is nothing but a finite machine. This finite automata is used to tell whether the string is present in the language or the string is not present in the language. So it is a simple method of describing a set of valid strings. When we say a string is valid, if a given string is accepted by the language, then it is said to be a valid string, which means the string is present in the language. Invalid string. If a given string is not accepted by the language, then it is said to be an invalid string, which means the string is not present in the language. Have a look at this diagram. Same what I said is, I need a finite automata, so that if I pass any input, so then it should provide an output either yes or no. So if I send any string to the finite machine, I should get an output that yes, the string is accepted by the language, or I should get no, which means the string is not accepted by the language. So there are some rules to construct this finite machine. Those rules and what are the rules to construct this finite machine will be discussed in the next class.